Get ready to blow your mind. We're diving into the ultimate cosmic mystery, black holes exploding. Before we go boom, let's take a step back and explore what makes these dark dynamos tick. You might picture a black hole as a space vacuum, gobbling up everything in its path like some kind of galactic Pac-Man. But there's so much more to it than that. A black hole is actually the collapsed remains of a massive star, an intense gravitational monster warping the fabric of space around it. Buckle up and let's blast off. A black hole isn't a void or an emptiness. It's actually the universe's densest objects, crammed with more matter than you can shake a star at, squished into teeny tiny space. This cosmic powerhouse's gravity is so intense that it outsmarts even light itself. Its escape velocity beats the speed of light, trapping everything within its grasp. So how do these gravitational giants form? The most likely scenario involves a supernova, an explosive finale to a massive star's life cycle, leaving behind an unyielding remnant known as a black hole. Get ready for some mind-blowing cosmic collisions. Imagine a star, roughly 25 times our sun's size, reaching the end of its life and unleashing an epic explosion known as a supernova. While its outer layers are blasted into space at incredible velocities, the core gets crushed under an intense gravitational squeeze, only if it has enough mass to begin with. This cataclysmic collapse transforms it into what we call a stellar black hole, typically having just a few times our sun's mass. But that's not all, because lurking in the universe are these behemoths known as supermassive black holes, each boasting masses millions or even billions of times greater than our star. Let's dive straight into the cosmic danger zone. What happens if we tumble headfirst into one of these space monsters? First off, no escape is possible once you cross that event horizon and fall towards its singularity. But hold your breath, because you'd most likely be vaporized long before reaching this point due to intense gravitational forces and extreme radiation conditions. Now let's talk about spaghettification, because that's what would literally happen if you got too close to a stellar mass black hole. As gravity pulls you towards it feet first, the force on your feet becomes thousands of times greater than on your head. This extreme difference in gravitational pull stretches and tugs at your body like overstretched taffy. By the time you reach the event horizon, you'd be a long, thin stream of matter. Scientists call this disintegration spaghettification. But here's the surprising part: because you'd be torn apart so early on in the process, you probably wouldn't even have time to feel any pain before becoming one with space. As we're talking about black holes and their mind-blowing power, let's dive into what happens when a star or even gas clouds get too close to one. Some black holes are so hungry, they just can't resist snatching up nearby matter, whether it's from an orbiting companion star or a surrounding gas cloud. Once this material gets pulled in, it starts to swirl around the black hole like water down a drain, forming what scientists call an accretion disk. This disk is where things get really intense. Everything moves at incredibly high speeds, causing temperatures to skyrocket up to millions of degrees. The result: a blast of high-energy X-rays shooting out into space. It's yet another mind-bending demonstration of the extreme nature of black holes. Let's talk about the main players on our cosmic stage, the different types of black holes. You've got your intermediate black holes, with masses ranging from a whopping 100 to 100,000 times that of our sun. Imagine something massive like that lurking in space. Then there are the supermassive black holes, which can weigh billions of solar masses and are found at the center of galaxies, including our own Milky Way. And finally, we have microscopic black holes. These teeny tiny monsters would be less than a grain of sand, but still pack an immense gravitational punch. Now you might wonder, can a black hole ever go boom? The answer is no. By definition, black holes are the ultimate cosmic vacuum cleaners. Once matter slips in, it's gone forever and they just keep growing. Scientists continue to unravel the mysteries of these enigmatic objects, but one thing remains certain: black holes are truly among the universe's most fascinating and bizarre phenomena. Black holes are the universe's ultimate powerhouses, warping space and time in their vicinity. Their insatiable hunger for everything around them leaves nothing escaping once it crosses that invisible point of no return, the event horizon. They just keep getting bigger as they devour stars, planets, and even other black holes, growing like cosmic behemoths. But according to renowned physicist Stephen Hawking's groundbreaking theory, these vacuum-sealed prisons aren't completely one-way doors. They slowly release a form of energy known as Hawking radiation, which is essentially the quantum equivalent of radiation from heated objects, but in this case, it's black holes emitting particles and losing mass over incredibly long periods. The mind-blowing fact about black holes is they don't last forever. Even the smallest ones can disappear over time through a process called Hawking radiation. However, it's an incredibly slow process that takes billions of years and only happens when these cosmic monsters aren't snacking on other matter or energy. Meanwhile, the origin of our universe, the Big Bang, still leaves scientists scratching their heads. What exactly triggered this monumental event remains a mystery, with theories like string theory attempting to fill in the gaps. Until we have concrete evidence, the singularity, a point with no dimensions, is all we can call it, drawing parallels with black holes, but without any direct connection between the two cosmic phenomena. Math can precisely depict what occurred just moments after our universe's singularity began to inflate, but it remains powerless when trying to decipher its initial state. Contrary to popular belief, black holes cannot explode. Instead, they'll gradually vanish due to Hawking radiation evaporating over time. It's highly unlikely for a black hole to push things away since its nature is to attract and pull matter inwards towards an inevitable doom. If such a cosmic entity were near Earth, the result would be catastrophic as life, along with our planet itself, would succumb to its relentless gravitational pull. However, there's an intriguing theoretical possibility as a black hole ages. It might transform into a white hole, essentially the exact opposite of a black hole, where everything is expelled outward instead of being drawn in. Thanks for hanging out with us. We're stoked that you got some new knowledge from this clip. If you haven't already, don't forget to hit that subscribe button so you can stay updated on our latest edutainment content. A thumbs up would be awesome too. It helps others find these cool videos. And if you're craving more mind-blowing facts like these, be sure to check out the link we've got for you in the description box below this video. Keep exploring and we'll catch you in the next one.